Alright, this is Night Sky Jeff, and this is the video we've all been waiting for, or that I've been waiting for some time to make, at least. This is going to address Kyle Adams and Potter's Clay regarding claims that they have made about the size of the Earth's shadow on the moon during a lunar eclipse. I'm going to play the Potter's Clay video first, which Kyle's video is derived from. There's no meaningful audio in Potter's Clay video, so I have it muted. I'm just going to play it and kind of give you a narration, a sense of what it's saying. Applying common sense regarding solar and lunar eclipses. The sun is 93 million miles away, hitting an object with a diameter of 2,159 miles. The shadow cast 238,900 miles away appears to be about 70 miles wide. So, first of all, this is supposed to be referring to the 2017 total solar eclipse that happened in August, almost exactly 5 years ago now. Now, he says the sun is 93 million miles away. He doesn't say whether it's 93 million miles away from Earth or 93 million miles away from the moon. The distance matters. The shadow on the Earth for the 2017 August eclipse was about 70 miles wide. But this distance, 238,900 miles, that is the average distance between the moon and the Earth. That is not the actual distance that the moon was during this eclipse. And 93 million miles is only the average distance between the Earth and the Sun. It's not necessarily the distance between the Earth and the Sun on the date of this eclipse. So his numbers, this number is correct, the diameter of the moon, and this number is correct, the diameter of the shadow on the Earth. But these numbers, 93 million miles away and 238,900 miles away, those numbers are inaccurate for the eclipse he's referring to. If that is indeed how light works, and an object with a diameter of 2,159 miles casts a totality shadow 70 miles wide from a distance of 238,900 miles away, then if we bump up the object 4 times, it's actually about 3 2/3. The Earth is about 3.67 times, the Earth's diameter is about 3.67 times the moon's diameter. Shouldn't that result in a shadow that's only 4 times as big? And so here's the problem. It doesn't seem to be the case because obviously the moon moves through a much larger shadow than simply 256 miles. The moon moves through a shadow that is larger than the moon's diameter for sure. So this is the arrangement he has, and he uses a simple proportion, a simple ratio. The ratio he comes up with is 30.84. Or the factor in his ratio is 30.84. Basically, 2159 over 70 equals 30.84. So therefore, 7,917 divided by 30.84 gives you about 257 miles wide. So what is the flaw in his geometry here? What is the flaw in his geometry here? Well, let's go back. The flaw in his geometry is that this math only makes sense if the total length of the moon's umbra is the same as the total length of the Earth's umbra. But if you watched my video about calculating the length of an umbra from a few weeks ago, or a month or two ago at this point, you will realize, and I'll put a link for that up here somewhere, you'll remember that the size of an object changes the length of its umbra. So the moon casts an umbra that goes out to here, But the Earth casts an umbra that goes way out here. In fact, if the moon and the Earth were the same distance from the sun, the length of the Earth's umbra would be 3.67 times the length of the moon's umbra, because the Earth's diameter is about 3.67 times the moon's diameter, which means that these lines here are skewed in too tight. It should be a much shallower angle going out this way, a much shallower angle going out. So that is the mistake that Potter's clay makes, and Kyle Adams has latched onto this mistake and is essentially betting his life on it. He is convinced that Potter's clay has made no mistakes in his analysis of eclipses. So let's see and hear what Kyle has to say.
Here we go. Let's talk about proportions for a moment here.
Okay, so he shows that he knows how to do proportions. Okay, he shows us a simple proportion table here. 18 over 9 equals 15 over 7.5. Okay, he knows how to do proportions. So now let's get to the moon.
Has a diameter of 2,159 miles. And during a solar eclipse, when the moon casts its shadow onto the Earth, the moon's umbral shadow is 70 miles wide.
Not during a solar eclipse, during a specific solar eclipse. During the August 2017 total solar eclipse, the moon's shadow on the Earth was 70 miles. Why was it 70 miles? It's a combination of how far the sun was from the moon and how far the moon was from the Earth. That is what determines the width of the umbra on the surface of the Earth.
So let's hold them to that standard. If the Earth is a ball, a lunar eclipse shadow should be proportional to a solar eclipse shadow.
No, it should not. No, it should not. And I'll show why in a moment.
So if the Earth's diameter is 7,917 miles, and it is proportionate with the moon...
It is not proportionate with the moon.
How big should the Earth's umbral shadow be when it hits the moon? We take 7,917 and times it by 70, and next we divide that by 2,159. That gives us a total of about 256 miles.
So Kyle is simply repackaging Potter's Clay's video. There's very little new that's been presented here.
But please notice how that is significantly smaller than the size of the moon. If the Earth's umbral shadow is that small, this is what we should be seeing. Now let's go take a look at how big NASA claims the Earth's umbral shadow is.
During an eclipse, it would go something like this. First, the moon passes through what's called the penumbra, where the sun's light is only partially obscured. This results in only a slight darkening of the moon. As the moon continues along its path, however, it enters what's called the umbra, where all direct light from the sun is blocked.
Okay, so you can see that, and again, this is woefully not to scale, but you can see that the umbra here is wider than the moon.
Please notice how they show the umbral shadow as being bigger than the moon itself.
Yes.
And here they go again.
About twice a year, this puts the moon in...
This is a much better animation. This might actually be to scale. So it's showing you the moon's shadow extends this far. The Earth's shadow extends much, much, much farther. Much farther. About 3.67 times as far. And so you can see that the moon's umbra on the Earth is very small.
In just the right position to pass...
While the Earth's umbra on the moon is bigger than the moon by far.
Shadow, causing a lunar eclipse. As the moon passes into the central part of the Earth's shadow, called the umbra, it darkens dramatically. Once it's entirely within the umbra, the moon appears a dim red due to sunlight scattered through the Earth's atmosphere. In fact, if you back home, you'll have planet's long shadow.
Definitely is not proportional with the moon shadow.
That's right. Oh, I'll let you hear exactly what Kyle says here.
Way bigger than the moon itself. So NASA's Earth shadow definitely is not proportional with the moon shadow over the same distance.
That is correct. The shadow of the Earth cast the same distance. The shadow of the Earth cast onto the moon is the size of the Earth's shadow cast on the moon is not proportional to the size of the moon's shadow cast on the Earth. At least, not in the same proportion as the Earth's diameter is to the moon's diameter.
Okay, so let's double the size of the Earth's shadow in this equation here, so it is more in line with what NASA claims.
Excuse me? doubling it to make it more in line with what NASA claims? No. NASA claims that this number here is bigger than this number here. All you've done by doubling this is you've made this number double.
If we make the Earth's umbra that big, how big should the Earth's proportional diameter be? 512 times 2,159 divided by 70. That tells us a proportional Earth should have a diameter of 15,791 miles.
Which is simply double the actual diameter.
So there are a number of different conclusions we can come to from here. Perhaps
most of them are wrong, but I'll let Kyle try to make them.
Earth is way bigger than NASA tells us it is. Unless NASA is lying to us about the size of the moon. Or perhaps lunar eclipses are just not caused by the Earth's shadow. If you have seen my other videos about lunar eclipses, I can hope you will agree with me on that.
Okay. I don't think there's anything more of substance. Abolish NASA. Yeah. So there's like nothing of substance there. So then, what has he done wrong, and how can we correct it? So again, Kyle is convinced for some reason that the size of the Earth's umbra on the moon should be proportional to the size of the moon's umbra on the Earth. And he's doing this, he's using this relationship here. So, what I attempted to show him, what I attempted to teach him, and I've been failing pretty miserably at this, but I would like to believe that this is not a defect of mine, is I've shown him that the only way that arrangement can hold true is if the umbral cone of the Earth is the same length as the umbral cone of the moon. So what I did, I made him tons of diagrams. This triangle here represents the moon. I've given the moon a diameter of 1. Basically, I took the moon's diameter and divided it by itself to give me a diameter of 1. And then I took the Earth's diameter and divided it by the moon's diameter, and that gives us the factor of how much bigger the Earth's diameter is than the moon's. So we have a diameter of 1 and a diameter of 3.672. I made the umbral cone end at a distance of 6, or a distance of a distance of 6. And 5.581 units out, the umbral shadow is 0.07 units wide. Also, 5.518 units out, the Earth's umbral shadow is 0.256 units wide. And this is 3.672 times that. And again, the only way this works is if these two umbral cones only extend the same distance. They are both 6 units long. But that's not how things work in reality. In reality, the size of an object affects its umbral cone, the length of its umbral cone. So I have these two objects, C and D. They are the same distance away from this light source. You can see that object C's umbra extends 5, 10, 15, 20, 21.4 units. And object D's umbra only extends 5.6 units out. Now, as it turns out, the ratio of 5.6 to 21.4 is just about the ratio of the diameter of circle D to the diameter of circle C. So he had, at one point, agreed with me that the distance that the umbra extends is dependent on the size of the object casting the shadow. Circles C and D are the same distance from light source A, but circle C is larger than circle D. Circle C casts a longer umbra than circle D. And Kyle said he agrees. So I kept trying to explain to him that Potters-Clay's analysis and Potters-Clay's math relies instead on the umbral cones being the same length. But we've just shown that the Earth's umbral cone should be about 3.67 times longer than the moon's umbral cone. Now, when I do that, when I make two new triangles, again, diameter of 1, diameter of 3.672, When I make these two triangles congruent, no, not congruent, when I make these two triangles similar, that is proportional to each other, basically I've taken this triangle and grown it 3.672 times. Again, we have a distance of 0.07 here for the width of the umbral cone at some particular distance. But the width here is not 3.67 times 0.07. The width here is much, much wider. It's, let's see, 10, 100, it's almost 400 times wider. Look at that, almost 400 times wider at the same distance away. And that's because if you want that proportional number to be the width of the umbral shadow, you instead have to do this. You have to take that distance here, the distance away from the object here, and you need to multiply that also by 3.67. And then you will get a proportional width to the umbral cone. I tried to show this to him many ways. I explained to him that Potter's Clay's diagram showing the two shadows was wrong. So he had, where is a picture of it? Okay, yeah, so this diagram here. He has the umbral cones being essentially the same length. And I showed that this is really the diagram that he should have created. He should have created a diagram. This is the moon's umbral cone, and then you have 1, 2, 3, and 2/3. 3.67 times longer the Earth's umbral cone should be. And when you put the moon here, you can see that the moon is not as wide as the umbral cone that it's in. Now, I have attempted to get him to understand this many, many ways. Recently, and I tried desperately to get him to draw me a diagram. He has an art degree. You know, I tried desperately to get him to draw me a diagram, and he really, really refused. To the point where he said I was bullying him to do it. And I guess at the end I was. I desperately wanted him to draw a diagram. So he finally did. He finally drew this diagram. Now he says, let me find the comment. Okay, he says, I know, oh, you can't see that. There we go. I know this diagram is not perfectly drawn, but it perfectly conveys my point, that the shadows do not have to have the same length in order to have proportional eclipse shadows. So let's look at his diagram. He has two triangles. One has a base of 2159 miles, the other has a base of 7,917 miles. He has, at the same distance away from the base, he has these two black lines. This one has a length of 70 miles, and this one has a length of 256 miles. But you'll notice that this triangle's pinnacle is at the blue line, and this triangle's pinnacle is not at the blue line. It's longer. So this is the diagram that Kyle, who has an art degree, this is the diagram that Kyle presented to me. And I looked at this diagram and I said to myself, like, wow, how does that work? So I inspected his diagram. I looked rather closely at it because I am suspicious of pretty much anything that a flat earther presents. And sure enough, his diagram is improperly proportioned. If this distance is 2159 miles and this distance is 7917 miles, then this black line should be 3.67 times as long as this one. But like looking at it with my eyes, I was like, there's no way that's almost 4 times as long. And also this line, if this is 70 and this is 256, then this should also be about 3 2/3 times that length. And it doesn't quite look like it is. So I analyzed his diagram. What he says is 7,917 miles is actually just about double this. So his proportions are wrong here. The base of his bigger triangle, this ratio is not true. 2159 to about 2 times that. And so if this is 70 and this is supposed to be 256, it's actually only about 175. It's only about 2.5 times as wide as this. So he lied with the numbers. Maybe he doesn't think he lied, but he drew a terrible diagram. Now, I corrected his diagram. I draw a lot of diagrams for him. So I corrected his diagram. Look what I did here. I created 2 triangles, one with a length of 2159 here, the other with a length 3.67 times that, 79.17. And then at a certain distance, I found where the width of the triangle is only 7 units, and along that same line, the width of this triangle is 27.6688 units. Okay, so we have that proportionality. This divided by that equals this divided by that. But oh, would you look at it? The pinnacles of these 2 triangles are at the same height from their base. That is the only way that you're able to get the proportionality of the width of the triangle at this length to be the same as the proportion of the bases of the triangles. Now, when I said that this diagram has the proper proportions and look, the umbrae extend to the same length, Kyle then deleted his bad picture, his bad diagram, and my analysis of it, and he claimed that I was now saying that the Earth's and the Moon's umbrae should, in fact, be the same length. By removing this context of his bad diagram, his bad disproportional diagram, which I corrected the proportions to, he thought that was some sort of victory for himself. And then I love making diagrams for this guy, even though he doesn't really learn from them. And then I said, okay, I'm going to make another diagram where I have a third triangle. This third triangle here is similar to this one. It's been grown by 3.67. And look, the width here is 7, and the width here is almost 6, it's like 64.5. So again, much, much wider than simply 3.67 times this. 7 times 3.67, that's going to bring you between 21 and 28, somewhere around like 25.5. This is way more than that. Oh yeah, 25.5, obviously, 25.6. So again, in order to get the width of this triangle to be 25.6 units, I had to take this length, this distance here, and multiply it by 1, 2, 3, and a little bit more. Oh yeah, 1, 2, 3, and 2/3. And then this length and this length are in the same proportion as this length and this length. So all of this is to say, Kyle Adams, the proportion that you're looking for is not the right one. The Earth's umbra extends 3.67 times as far as the Moon's, which means the width of the Earth's umbra on the Moon is not going to be simply 3.67 times the width of the Moon's umbra on the Earth. And then for good measure, again, because I said that the numbers that Potter's clay used were wrong, for good measure, I built this table. This table is assuming the Earth's radius, the Moon's radius, and the Sun's radius. It's using these distances between the Sun and the Earth, perihelion, aphelion, and the average. And it's using these distances for the Earth-Moon system, perigee, apogee, and the average. And so this shows the range of, this top table shows the range of the lengths for the Moon's umbral cone. from just shy of 228,000 to almost 236,000. And then I plug these values in down here for the minimum, maximum, and average length of the moon's umbra. And then I use distances between the Earth and the moon that show that the maximum the lunar umbra can be on the Earth during the total solar eclipse is just under 168 miles. And this table shows you that the distance between the Earth and the moon and the sun, those distances really do have a strong impact on how big the lunar umbra on the Earth is during a total eclipse, total solar eclipse. That 70-mile eclipse that we had 5 years ago, in 2 years, the umbra width is going to be something like 123 miles. And then in 2045, it's going to be something like 100. No, I don't remember now, but like somewhere like 140 miles wide. But yeah. So anyway, I'm sorry this video was so long. It's been 26 minutes now. I don't like to make videos this long, but I really wanted to address both of their videos and show exactly what Kyle was doing wrong. I don't know if he's going to watch this video. I don't know if he has the attention span for this video. But anyway, thank you for watching. This has been Night Sky Jeff, and as always, keep looking up.